The current spacecraft at Saturn is Cassini on its second extended mission, the Cassini Solstice mission, which is expected to be completed in 2017. It continues to watch the planet-sized storms in the atmosphere.
Great white spots on Saturn are these large storms that erupt about once every year on Saturn. A year on Saturn is 29 Earth years. The great white spot that erupted in December 2010 initially presented itself as a small little white fluffy cloud that came up, and various instruments on Cassini were seeing it, and ground-based instruments seeing it as well. And as the days progressed, the storm got larger, and then it got sheared from the top and the bottom of the storm on either side of it, and it wrapped all the way across the planet. We'd never before been able to study a storm system of this magnitude in the infrared, so we are very fortunate at this time to have a spacecraft in orbit and excellent ground-based facilities, allowing us to make a historical record of this great white spot. And that will allow us to compare it in future generations when the next one happens.
Another phenomenon is a hexagon of clouds around the North Pole of Saturn, which has recently come into the light.
Cassini has been in orbit around Saturn for 9 years, and we've been following this hexagon which surrounds the North Pole. It's bigger than 2 Earths, and it's a wandering jet stream. But it's been winter in the north, so we have not been able to see what's at the center of the hexagon. But now it's spring, and what we found at the center of the hexagon is a Saturn Hurricane. This is a view from directly over the North Pole, which is made possible by the orbit of the spacecraft, which is now taking us over the poles. The winds are flowing at 300 miles an hour, which is 4 times hurricane force. The fluffy white clouds in the center are about the size of Texas. We can use special filters to measure the heights of the clouds, and red are low clouds and the green are high clouds. We call it a Saturn hurricane because it has the eye, it has the high winds, but it's different from an Earth hurricane because it's locked to the North Pole. And unlike a terrestrial hurricane, there's no ocean underneath. And that's one of the puzzles we're trying to figure out.
A phenomenon first observed on Saturn by Pioneer 11 in 1979, and common to Earth as well, are polar auroras. These magnetic-generated light shows are far more spectacular on Saturn, rising hundreds of miles above the planet's poles. And unlike on Earth, where bright displays fizzle after only a few hours, auroras on Saturn can shine for days. Auroras are produced when speeding particles, accelerated by the sun's energy, collide with gases in a planet's atmosphere. The gases fluoresce, emitting flashes of light at different wavelengths. The Hubble Space Telescope has been watching them closely.
Starting in 2016, ending in 2017, these orbits will take us up and over the north and south poles of the planet.
We're actually going to dive in between the innermost edge of the D-ring and the upper atmosphere of the planet itself.
From that, we're going to learn how is Saturn constructed from inside out.
We'll also get the magnetic field of the planet, the mass of the rings for the very first time, and get to sample a place that no spacecraft has ever flown before.
This is a mission that cannot be duplicated. So we really want to take advantage of this opportunity to observe seasonal variation in the system.
Uranus has had only one visitor from Earth, Voyager 2. Like the other gas giants, Uranus has a ring system a magnetosphere, and numerous moons. There the similarities end. Images from Voyager revealed a featureless atmosphere with no cloud patterns or storms. Uranus differs in its orientation as well. Tilted onto its side, its poles lie where other planets have their equators. Its magnetosphere is off-center and tilted as well, generating an unusual asymmetrical field. This causes Uranus's auroras to be well off the poles. Observations from Earth have shown seasonal change and increased weather activity as Uranus approached its equinox in 2007. The wind speeds on Uranus can reach 250 meters per second. Although there are currently no scheduled missions to Uranus, there have been several proposals put forward, both jointly from ESA and NASA and JPL, including both nuclear and solar-powered probes and an atmospheric descent probe. Ion propulsion is favored because it allows a greater mass to be sent to the planet. Ideally, a probe could be launched in 2020 with a 13-year cruise to Uranus. As this is considered a low-priority mission, no funding has yet been allocated. The eighth and last planet in our solar system is Neptune, the last of the gas giants.
Well, you know, the key to planetary science is that you really have to go places to get the resolution, to get up close enough to really see what's going on. We want to get up close and personal.
New Horizons is the first really of a whole new breed of spacecraft that is focusing on a very specific task.
For this mission, the questions are basic. What do Pluto and Charon look like, and what are they made of?
We had to really be disciplined and say, we can't do everything. Let's focus on the primary questions and design the instruments to answer those primary questions.
New Horizons was built light and launched on a very powerful rocket, breaking all previous speed records when it left Earth on a solar escape trajectory at 16.26 kilometers per second. The spacecraft passed the orbit of the Moon in just 9 hours. It then cruised for just 1 year to reach Jupiter, where it was given a gravity boost, increasing its speed by 2 kilometers per second and cutting the travel time to Pluto by 3 years. New Horizons was the first to visit the dwarf planet and Charon, its largest moon. Pluto failed one of the 3 criteria to remain a fully fledged planet. It has not cleared the neighborhood around its orbit. Pluto is part of the Kuiper Belt and not the only dwarf planet residing there. This is an image of Pluto at its closest approach. It still remains a treasure trove of scientific questions and hopefully answers about the origins and evolution of the solar system. From Pluto's flyby, it is on to the unknowns of the Kuiper Belt. The most numerous objects in the solar system are the ice dwarf planets that make up this donut-shaped region on the edge of the solar system.
It's kind of like the asteroid belt, but much bigger. It has hundreds of times more objects in it than the asteroid belt.
The spacecraft will visit some of these objects in its travels.
Once you have the orbit, and we know where the spacecraft is and where it's going to be, we can figure out how much fuel the spacecraft is going to need to use to get to these objects.
After some careful calculations,
it looked like we might actually have to burn the engines to miss the object, which was a pretty exciting concept. You know, it's a good thing we looked, because you wouldn't want to run into one of these things.
These cold classicals, they're pretty much as they were 4.5 billion years ago. They're little fossils. That's incredible. We have no idea what they're going to look like.
New Horizons will continue to explore the outer solar system until 2026.